Hello, this is William from Visual Components. In this video, I'm going to show you how to simulate a depalletizing operation using the Works library. Now, a depalletizing operation is where you're taking something off a pallet and putting it somewhere else. In this case, we're going to use a robot to take things off the pallet and put them on a conveyor. To get started, make sure you clear the 3D world of all components. We'll then go to the eCatalog panel, and under Models by Type, click Works, and this collects all the components and layouts in the Works library for you. And since we're using the Works library, let's go ahead and add a Works Task Control to our layout. So I'll add Works Task Control version 3. Its location does not matter in the 3D world, just make sure it's in your layout. Let's now add a process component. So I'll add a Works Process Component version 3. So let's make this eCatalog a bit bigger. So it's this item here. So I'll drag that into the 3D world. And now we want this process component to create a pallet with parts on it. So let's first add the pallet that we want to create. So in the eCatalog panel, we'll expand Products and Containers and click Visual Components. Let's now do a search for a pallet. So I'll just type in pallet. And we have a couple items. So let's add a Euro pallet. So I'll drag that item into the 3D world. And its location doesn't matter, so I'll just put it next to my task controller here. I do need to copy its name. So in the Component Properties panel, I'll right click and click Copy to copy that name value. Then go to my process component here. And in the Component Properties panel, we want this process component to create a Euro pallet using a create task. So by default, task is set to create. And we can pass a list of component names that we want to create. So I'll just paste in that Euro pallet name. I could give it a new product ID, but I won't. So in this case, the component's name will be its product ID. So I'll create the task. And if I run the simulation, notice it does create the pallet. Now we need to add the part we want to be on top of the pallet. That can be created, so let's reset. And then let's clear our display search box here in the eCatalog panel. And let's look for a cube. So I'll just do a search of cube. And we have one item here, so I'll drag that into the 3D world. And once again, its location does not matter. But we do need its name. So in the Component Properties panel, I'll go ahead and copy that name. And if you want a quicker way of doing this, what you could do is you could go to the Cell Graph panel and notice under Products and Containers, that category, you can see those two items there if you need to quickly reference their names. So I'll go back to my Works Process component here. And now instead of creating just one cube, we want to create a pattern of cubes. So after we do the create task for the pallet, let's add a create pattern task. And notice you create a single component by referencing its name. So I'll paste in that name of the cube. And for the pattern, we don't know how many yet, so let's just keep the defaults. And let's just create one cube in the beginning. So I'll set the end range to be 1, so just one cube will be created. I'll create the task. I'll run the simulation and stop it. You can see that the pallet's created and the cube, but the location of the cube is not good. We want it to be on top of the pallet so we can create more. So with the simulation stopped, I'll select the cube, and then on the mini toolbar, I'll click Move. And notice this gives me access to the Move tool. And let's actually just move the cube up along the Z-axis. And now I'm going to use a shortcut to snap a corner point of this cube to a corner point on this pallet here. I'm going to hold down the Shift key. I'm now going to point at a corner point in the cube, like so. And now if I hold down the left mouse button, notice I can now drag the cube anywhere in the 3D world based on that point I have selected. So if I zoom out just a bit, I'll drag the cube to that corner point there. I'll let go of the left mouse button. And now the cube is at that location there. I'm going to press the escape key to exit out of the shortcut command. So what I basically did was snap the cube to this location here based on this point of its geometry. And that location looks good, so let's now teach this and store it in our Works Process components. So the next time we create the cube, it will be created here. So I'll select the Works Process component in the 3D world. And if this is difficult for you to select, just go back to your Cell Graph panel. Notice you can select it here under the Works category. And then in the Component Properties panel, we're going to update our create pattern task. So I have it selected here. And now let's actually create more of those. So for end range, we'll just set this to be 9999. We're not going to create more than 10,000 cubes, so this is just a safe range. And then for the amounts, that looks fine. But we want to teach the location. That's what we're concerned with. So if I scroll down, you can see I have a button here to teach location. And you could give the name of the component you want to teach to the process component, or you could just teach location of components that are attached to this process component or contained in it. So you want to leave this checkbox selected here if you want to do that. So now if I click Teach Location, remember the pallet and the cube were created by the process component, so they're attached to it, and that's why you have their stored location here for the cube and the pallet. So if I reset the simulation, run it again, Notice the cube is now created at that stored location, that taught location. So let's go ahead and stop the simulation. And we want to create more than one cube on the pallet, so let's take some measurements real quick. So I'm going to clear the output panel. I'll then go to the Tools group and click Measure. And let's first get the measurement for the cube along the x-axis. So I'll measure from that corner point and this corner point in the cube, so it's a length of 300. Let's now measure from this corner point in the cube to the corner point all the way over here on the pallet. That's 900. And now let's measure from this corner point in the cube to this other corner point of it. That's 300. So it's 300 by 300 cube. And now let's measure from this point here to the width of the pallet, and that's 500. So let's actually just fit 2 rows of the cubes, and let's do a pattern of about 3 more, so a 2 by 4. I'll press the Escape key to exit out of the Measure tool, and I still have the Works Process component selected. I'm now going to change this Create pattern, the amounts. So the amount on the x-axis, let's make that to be 4, and the amount on the y, let's set that to be just 2. And do we care about the z-axis layer right now? Let's not do it in this video, let's just keep it simple. But our step size, that does matter. So the step size is going to be that 300 along the x and the 300 on the y, and that's based on the measurements we just took. And to update our Create Pattern task, I'm going to click this button here called Replace Task. Notice it's updated here in the Insert New After Line property. And you can go to the Output panel, you can see that, notice we get feedback saying that that second task for Create Pattern Cube, it was updated with these values. So if I reset the simulation and run it again, there are our cubes. Let's go and stop the simulation. And visually this probably doesn't look too good, so let's actually go to the 3D World toolbar and let's change our render mode to be face edges shaded, and that looks fine. This way we can clearly see the edges of the cubes that were created. And let's also make our Works Process component look more like a conveyor. So I'm going to reset. Actually, we can do it while the simulation stopped, sorry. We'll now go to the Component Properties panel, go to Geometry, and instead of showing the box, let's clear that Show checkbox here. We want to show the process component as a conveyor, and let's give it actually a couple more feet, so let's use amount of feet of 4. And now we need to change the length and width of the Works Process component, so go back to the Default tab, and if I scroll down, we have these properties called C-length, C-width, and C-height. So conveyor length, conveyor width. Let's make the conveyor length to be 1500. And the width, let's make that to be 1000. And now if we adjust our view, we can see, yep, the pallet fits nicely on the conveyor. And now after we create this pallet and the cubes, we want them to move out of the conveyor. Now if we were going to move them all together, we need to merge them or attach these cubes to the pallet, so when the pallet moves, the cubes move with it. So let's reset. I'll then go to the Component Properties panel. And after we create the pattern of the cubes, we're then going to use what's called a merge task. So notice we can pass a parent product ID, so this is the component that will be the parent of the components we list here, or all components that are currently in the Works Process component. In this case, we're going to use the palette, so it has the default component name as its product ID, and the components we're going to attach to the palette, or merge with it, is the cube. So we'll just type that there, and we actually could clear this checkbox for the all. So if I create the task, and then add a transport task after this merge, so I'll set task to be transport out, and let's go ahead and transport out the palette to test. So for a list of product IDs, I'll just transfer out the palette, and since the cubes will be attached to that palette, they'll move with it. Let's create the task. So now I have 4 tasks in the Works Process component. In order for the palette to transfer out, I have to connect the conveyor to the end of this process component. So let's go to our eCatalog panel. And then under Models by Type, let's expand conveyors, click Visual Components, and then add a conveyor item. And use the PMP command to plug the conveyor into the Works Process component. And let's adjust its length and width. So the length is fine. Let's set conveyor width to be 1000. And see how this works out. So if I run this simulation, the palette and the cubes are created, and notice they merged and they're moving together out of the Works Process component onto the conveyor. So if I stop the simulation, and if I select the cube, you can see that the PMP command is active, so I can see what this cube is attached to, and it's pointing at the palette. And if I select the palette, notice it's attached to this conveyor here, or its path. So that's how the hierarchy is working. So let's actually reset, and now we want to stop the pallet of cubes, which can then be picked by the robot or depalletize. So let's add another works process component. So I actually will just copy this one I have in the 3D world, and then move it over here to the end of my conveyor line. And now we want to clear the tasks that were in the original works process component. And to do that, let's go to the component properties panel. And notice you have this button here called clear all tasks. So I'll click that. And notice that we no longer have any task in this process component. And the first thing we want to do is transport in that pallet of cubes. So let's transport in any. And now when the pallet reaches this midpoint here, it should stop during the simulation. So let's speed it up just a bit. So there's the pallet of cubes, and we expect it to stop once the origin of the pallet reaches this midpoint here. And it does. And notice these process components, they're repeating the same process or executing these tasks more than once. That's why it keeps on creating this pallet of cubes, and they keep on being transported over here. So let's actually stop the simulation. And what do we want to do after we get the pallet of cubes over here? Well, we want to teach a robot to pick these cubes and place them on another conveyor. So we want to take the cubes off the pallet, and once they're all off the pallet, then move the pallet away and move the cubes in a different direction. So let's reset the simulation. And since we're going to be working with a robot, let's go back to the Works library. So under Models by Type, I'll click Works. And now let's find a robot controller. And in this case, let's use Robot Controller version 4. So I'll drag that into the 3D world. And we want our robot to reach the cubes, so I'll just move the controller over here. Let's now add and connect a robot to this work controller. So in the eCatalog panel, I'll expand robots, and then I'll click Visual Components. Let's add a generic articulated robot, so I'll drag that into the 3D world. I'll then use the PinPick command to plug the robot into the Works controller. So now it's attached, so if I select the Works controller and move it, notice the robot moves with it. And now I can assign a task to this robot controller. I can tell the robot to pick up those cubes and place them somewhere else. So let's actually copy this conveyor we have here. So I'll just clone it. And let's move it over here. And then let's use this ring to rotate the conveyor in place around the z-axis in its coordinate system. And that looks fine. I think the robot should be able to reach everything, but to make sure, let's go and select the robot in the 3D world. Let's go to the Component Properties panel. I'll click the Workspace tab and select the Envelope checkbox here. So this shows the area reachability for the robot. And that looks fine, but let's actually run the simulation real quick and make sure the cubes are within that space. So I'll just stop the simulation once the cubes reach here. And it does look okay, but what we could do is we could move the robot just a bit closer, so that looks fine right there. And let's also move the conveyor over here a bit closer to the robot, like so. Now, instead of using a conveyor, we probably need to make this a works process component. So I did make a mistake, I'm sorry, because the robot needs to know where it needs to place the cube. So it's a lot easier to just use a works process component that's modeled as a conveyor. So let's actually delete that conveyor, reset the simulation, and select this process component over here, and clone it. And then just unplug it from the other works process component. And just do the same we did to the conveyor earlier. So rotate it in place, and move it within reach of the robot. So remember, if you don't want the robot to place the item in the default location at this midpoint here, you can just teach location for the cube in this process component. Now, we want to clear the tasks that are in this process component. So in the Component Properties panel, I'll click the Clear All Tasks. And what does this component need? Well, it needs a cube. So for our tasks, we're going to create a need task. And what components do we need? Well, we need that cube, which has its component name as its product ID by default. So we need a component that has a product ID value of cube. So I'll create the task. And then we're getting the cubes from this process component over here. So it needs to feed those cubes to this conveyor and assign that feed task to the robot. So let's actually zoom in just a bit. And then after we transport in the cubes with the pallet, the cubes are still attached to the pallet, so we need to split them up. We need to detach them from the pallet. So after we transport them in, we're going to create what's called a split task. So this will split them up, and the products we're going to split up are the cubes, using that product ID. So I'll create the task. Let's now create a feed task, and the components we're feeding is the cube. The task name, let's just call this pick cube. And this allows you to clearly identify this task and assign it to a resource, in this case a robot. And the tool name and TCP name, we don't need to worry about that, but we want to feed all of the cubes, so all the components that are of this. But let's actually clear that out. It will just automatically know that there's more than one cube in the works process component, so we don't need to use this. If we selected this, it would actually feed everything in the works process component. So let's create the task, and now assign this pick cube task to the robot. So we're going to select the robot controller here, the works robot controller, and for its task list in the component properties panel, we just need to assign that task by its name. So pick cube, press the enter key, and let's go and turn off the workspace of the robot. So I'll select it in the 3D world, and then in the workspace tab in its properties, let's clear that envelope checkbox. And let's see how this all works out. So I'll run the simulation, and there comes the cube, and we expect the robot to pick up those cubes and place them on the other conveyor. And it picks that one cube and places it. Great. And we actually didn't tell the process component over here after it places the cube, transport it out, so we can fix that now. But everything looks good for the robot. Let's just make sure there's no reachability errors. So it picks all those cubes. We got 2 more. Come on, robot, you can do it. There we go. And then it finishes up. Great. So let's stop the simulation. And notice after the robot picks all the cubes, we need to transport out the pallet as well. So we need to add a transport task to this process component and a transport task to this one as well. So let's make this work. I'll reset the simulation. And we have this conveyor here, so I'll select it and clone it, and then plug it into the end of this works process component here. And then let's add a transport out task for this process component. So after it feeds the cubes, let's add a transport out task. And there's no more cubes left, so what we can do is we can just use the pallets ID or use the all checkbox. So let's actually just make things super safe by typing in EuroPallet for the list of product ID and create the task. And now let's copy this conveyor here and paste a new one. Notice when I was copying and pasting, I was using this shortcut here called clone from the mini toolbar. So you can access the mini toolbar just by directly selecting the component in the 3D world, like so. Let's now plug the conveyor into this other works process component, and then select this process component here and add the transport out task for the cubes. So after we get 1 cube, let's add a transport out. In list of properties is cube, but you could use the all checkbox if you wanted to. I'll create the task, and now if I run the simulation again, what we expect to do is that the robot will pick a cube, and once it's placed on this process component, it will go to this conveyor here. And there you have it. Great. And then after the robot picks and places all of those cubes or depalletizes, the pallet that's empty will then go down the conveyor line here. So let's speed this up. So far, so good. And make it a bit faster. And we got 1 more cube left. And yep, the pallet goes away. And then a new batch comes in, and the robot just repeats the process. Great. Now let's stop the simulation right here and zoom in. We can see that the approach and retract distance for the robot when it picks a cube, is not high enough, so it's actually colliding with these other cubes. So to make that change, let's reset the simulation. And now what I'll do, instead of selecting the robot or its controller, I'll select the works process component where the cubes are coming from. I'll then go to the component properties panel and click the advanced tab. And notice every works process component has its own set of pick and place properties for telling a resource how to pick something or place something at that station. So we're picking the cubes, so I'll set the pick approach. Right now it's set to 100. I think the height of the cube is 300, so let's use a pick approach of 400. And I'll type that in and press enter. And notice you can also define the pick direction, which in this case is the z-axis, and the pick delay, so how long the robot waits until it picks up the component. And then how long the motion for picking it up should take, and then if the robot needs to rotate anything. So if we actually reset and run this again, Let's see the robot pick that cube and have a safe distance for when it retracts up. And here comes the pallet. And now let's go and stop the simulation. And yep, there you go. So there's that new pick approach distance. And when I continue to run the simulation, the robot swoops over and places the cube over here based on the place distance that was set in this process component. So if I select it here and go to its advanced tab, you can see its place approach distance is 100. Now let's say we want to get crazy and change the pick direction. So instead of picking the top face of a cube, let's actually pick from the side. So in this case, it probably is going to be the y-axis. So let's reset. Select the works process component here where the cubes are coming from. And in the advanced tab in the component properties panel, let's set the pick direction to be the y-axis. So we do have an option for the negative y, but let's use y first, see how that looks. Run the simulation and speed it up. And let's see the robot get crazy. So I'll stop it here. Notice that the robot goes in, and it's actually fixated on picking the cube that's over here. So we probably need to change how the robot, what item the robot will pick first from this palette here. Let's do that. Let's go and select the works controller of the robot. And if you go to the component properties panel and click the advanced tab here, notice that it has some type of sorting function here defined by this pick by property. So the last component in is the first one out. So it actually was this cube over here at this end of the palette. So if we change this to be the first cube in, should be the first cube picked by the robot will probably pick one of these cubes here. So let's actually change the pick by to be first in, first out. And you could have some other options here for how you pick stuff, but let's reset. Run the simulation again and see how this works out. So what cube will the robot pick? It's going to pick that outer cube there. And notice it picked from the side of the cube along that y direction. And now it's going to pick again from that direction as well. So actually reset. And let's set the pick direction back to the z-axis. You usually don't want to pick the cube from the side. It might fall apart. So I'll select the works process component and set its pick direction back to the z-axis. Now, the last thing I want to show you in the video is how to teach the robot additional positions for picking and placing components. So what I'll do is I'll start the simulation and show you what I'm talking about. So I'll speed it up just a bit. And then when the robot picks up that first cube, I'll stop the simulation. Notice that when the robot picked up this cube, it went to that, approach position, and then it moved all the way over here in a joint motion to where it's going to place the cube here. So in between those two actions, I may want the robot to go to some safe position or a home position. And to do that, let's go ahead and go to the Program tab. And if I use the jog command to select the robot in the 3D world, in the Program Editor panel, you can see the robot has these pre-pick, pre-place, post-pick, and post-place subroutines that are created dynamically for you. And notice that they're referencing the task that's being executed by the robot, which is called pick cube. So the pre-pick subroutine, this is positions or statements you can teach a robot before it picks up the cube. And then you have this post-pick subroutine, so that's something that the robot can do after it picks up a cube. So let's say before the robot picks up a cube, we want the robot to go to some home position over here. So let's actually reset the simulation and then just move the robot along that first joint like so. And I'm going to teach it as a point-to-point motion statement. So this is a point-to-point motion statement in the pre-pick pick cube subroutine. Now after the robot picks up the cube, I'll select the post-pick subroutine here. And then let's move the robot over here and consider this like a home position. So what I can do is I can just reset, and notice the robot's at its initial joint configuration. So I'll add a point-to-point motion statement. So that's called P4. And if I now run the simulation, what we expect is the robot will go to that position of P3 first. So let's slow the simulation down just a bit before it picks up a cube. And yep, it did that. And now it should go to P4. It does before it places the cube. Great. Alright, this concludes the video. If you have any more questions, please feel free to go to our forum at forum.visualcomponents.com. And I hope you have a wonderful day.